differential equations, type 2, real world. A, linear motion, general. So if we look at 2016 question 10, we have at time t seconds, the acceleration a of a particle is given by a is equal to 8t plus 4. At time equals 0, p passes through a fixed point with a velocity of minus 24 meters per second, and we have to show that p changes its direction of motion only once in subsequent motion. Now, in order for an object to change direction, what will have to happen is that the velocity will have to reach 0 before it changes direction. So if you think about an object being thrown up, if you throw a ball up into the air, at a certain point its velocity will be instantaneously at rest, and then it will actually fall back down again. In other words, it changes direction. So if the velocity going up is positive, it'll reach the highest point, v will be 0, and then it'll fall back down again, and because it's moving in the opposite direction, you'll now have a negative velocity. So here what we want to see is, if we find the velocity equal to 0, how many times will this occur? So if it's only once, then we should find only one time when this is possible. Okay, so let's set up our equation. So we're given a is equal to 8t plus 4. So that's what we're working off. And if we're looking at our limits, well, what do we know at the start? Well, we know that the time at the start is 0 seconds, and the velocity at the start is minus 24 meters per second. We don't know anything about displacement here in this question for the first part, so therefore at the end, the time is what we're looking for, and we want to know at what time is our velocity 0. In other words, how many times does it change direction? So if we're looking at limits between v and t here, then our a that we're going to work off is dv dt. So we'll say dv dt is equal to 8t plus 4. And therefore, if we rearrange those to get our v's on the left and our t's on the right, we'll have 8t plus 4 times dt. So if we set up our integrals, then what we'll have is dv and 8t plus 4 dt. And our upper limits are always our end limits. So we'll have t and 0, sorry, not t and 0, 0 for velocity and minus 24 at the start. And in time, we'll have t and 0. Okay, so if we integrate dv with respect to with respect to v, so it's the same as integrating 1. In other words, we'll get v within the limits of 0 and minus 24. And if I integrate 8t, I'll get 8t squared over 2. And if I integrate 4 with respect to t, I'll get 4t. And again, my limits are t and 0. So if I sub those limits in, what do we end up with? Well, we end up with 0 minus 24. So remember, it's always upper limit first minus lower limit. And then that will be equal to 4t squared plus 4t minus, if I sub in 0 for t, and we're just going to be left with 0. And therefore that gives me 24 is equal to 4t squared plus 4t. So I'm clearly going to end up with a quadratic equation here. And I'm going to divide across by 4 to simplify. So what factors out there? Well, it multiplies to give us minus 6 and adds to give us 1. Must be 3 and minus 2. So again, factorising however you want. So highest common factor there is t. Highest common factor is minus 2. And then highest common factor again is t plus 3 and t minus 2. So if both of those multiply to give us 0, that means one of these factors has to be 0 or both have to be 0. So in other words, t plus 3 must equal 0. In other words, t equals minus 3. Or t minus 2 equals 0. In other words, t equals 2 seconds. Now, of course, we can't have negative time. Therefore, there's only one answer. In other words, there is only one time that the velocity is equal to 0. In other words, when t is equal to 2 seconds. So we can conclude then that p changes its direction only once. Okay, which is what they asked us to show. So we were getting 5 marks for getting out our integrated equation. So 5 marks for getting to this point, 5 marks for getting out our time, and then of course 5 marks for our conclusion with our evidence. So for the second part of the question, it wants us to find the distance. So it's the distance between our limits of t is equal to 0 and t is equal to 3. So in other words, if we're looking for distance, our limits are in terms of s and t. So of course we can't get s and t from our a here, but if we can find our velocity equation, then we can use our velocity equation is equal to ds dt. So in other words, if we look at dv dt is equal to 8t plus 4, and if you still operate off the method of finding your constant of integration, then you'd already have this equation from part 1. But because we're using limits on both sides, we don't have that equation, so I'm going to have to find that now. So if I'm looking at my start limits and my end limits, start being t is 0 and v is minus 24. My end limits, well, t is t and v is v. In other words, we don't know at what time. We're finding the general equation here for velocity. So therefore we'll have dv is equal to 8t plus 4 dt. In other words, if I integrate both sides, my upper limit is t and v. My lower limit is 0 and minus 24. So if I integrate, I'll have v with the limits of v and minus 24 is equal to 8t squared over 2, which we saw was 4t squared. And if I integrate 4, we saw that that was 4t. And that's within the limits of t and 0. So we have v minus 24 is equal to 4t squared plus 4t. In other words, our general velocity equation at any time is 4t squared plus 4t plus 24. Okay, so now we're going to use this to integrate with respect to displacement and time. So if I start with that equation, we have v is equal to 4t squared plus 4t minus 24. Our start limits and our end limits, well, starts from rest, starts at time of 0. Displacement is what we're looking for. Sorry, not displacement. Distance is what we're looking for. And therefore that means the t is equal to 3. Now, we have to be careful here because we saw in part 1, so I'm going to put a star next to this, that the time was 2 seconds before it changes direction. So, of course, if I am careful with this, what we could end up with is the overall displacement as opposed to the overall distance travelled. So, of course, I know it changes direction after 2 seconds. So, therefore, I'm going to have to actually work out the distance travelled after 2 seconds and then the distance travelled after another second, okay? So let's look at our velocity. Well, if I want to write velocity for integration, velocity can also be written as ds dt. So we have 4t squared plus 4t minus 24. So if I separate those two out, I have 4t squared plus 4t minus 24 dt. And then if I integrate both sides, my upper limit is 2 seconds, lower limit is 0, upper limit is s, lower limit is 0. So if I integrate 1 with respect to s, I end up with s, limits being 0, s and 0. And if I integrate 4t squared, I end up with 4t cubed over 3. So remember to add 1 to the power and divide by the new power. Limits being 2 and 0. So then s minus 0 is equal to 4 times 2 cubed over 3 plus 4 divided by 2 is 2 there. I'm just going to simplify that. 2 squared minus 24 times 2. And then obviously if I sub in 0, I'm just going to end up with 0 there. Okay, so let's tidy this up then. What are we left with? Well, we're left with s is equal to, so that gives us minus 29.33 meters. Okay, so that's the distance travelled after 2 seconds. So now we have to find the distance travelled after 3 seconds, but we know that it's changed direction. So we'll have to get the difference between that and the 29.33 to work out how far it's travelled in that time going from 2 seconds to 3 seconds. Okay, so if I look my start and my end, well, if I have my start time there was 0, my end time was 3. Sorry, I'm actually going to change that. I'm going to do it, you can do it of course from 0 to 3, but I'm going to just get the distance travelled during that last second there. So once it's changed direction, going from 2 seconds to 3 seconds. And then, so that should be t equals 3 there. So s is going to be, so s will be our 0 and our final is what we're looking for. So in other words, if I look at a little diagram over here, what we're saying is for 2 seconds it's travelled one direction and it's travelled a distance we now know of 29.33. And now we're looking at between t equals 2 seconds and 3 seconds. So in other words, it's started at 2 and it's ended at 3. So therefore, what is the distance travelled from this point? So we're taking that point to be 0, and we want to know how far it's gone between these two positions. And then we'll add those two distances on together. Okay, so let's look at our equation. Well, what did we have? Well, it's going to be exactly the same integral overall, so I don't need to integrate again. If I go back, I'm literally just going to start at this position here where I'm subbing in my limits. So we'll have S0 is equal to 4t cubed over 3 plus 2t squared minus 24t between the limits of 3 and 2. So I'll have s minus 0 is equal to 4 times 3 cubed over 3 plus 2 times 3 squared minus 24 times 3. And if I subtract the difference, then it's 4 times 2 cubed over 3 plus 2 times 2 squared minus 24 times 2. And therefore that gives me S is equal to 11.33 meters. And of course you can see it's positive, whereas in the previous case it was negative. And therefore that shows me that it has changed direction. Okay. So therefore overall, the distance travelled, distance, must be the absolute value of those two together. So the absolute value of minus 29.33 is 29.33 plus 11.33. So that gives us a distance travelled of 40.66 meters. Okay. And marks going for this then, we had 5 for getting the overall answer, and we had 5 for getting our distance equation, which is this here, okay? So we had a total of 25 marks, so we had 10, and then we had 15, which is 25. Okay.